Preprocessing is different, preprocessors are different. Once it recognizes, it can schedule the task of preprocessing to the preprocessor. The expanded file is generated. The expanded file is given as input to the compiler. This hash symbol indicates that there is a preprocessor. In the place of limit, it replaces the limit by 5. Hello everyone, it is Dr. Ravi Kumar by B. In today's session, we shall see how the pre-processing is performed. What is the meaning of pre-processing? The word pre-process indicates that before the actual compilation, certain processing have to be done. That is why it is called as pre-processing. If I do the macros as a pre-processing operation, then it is called as a macro pre-processing. In today's session, we shall see as to how the macro pre-processing can be done. If you see that the name suggests that pre-processing is different, preprocessors are different. That means the processor is a software. That is, a preprocessor is a software that takes the input file which is in .c extension or .c++ extension or .java file extension or any of these source program as input to it, and then pre-processes the file used for the purpose of macro expansion. If that is the case, the process that performs the pre-processing before the actual compilation begins, that is called as pre-processing. The software which does the task of pre-processing are called as preprocessors. If that is the case, there are number of steps involved between writing a program and executing a program in C or C++. Whether it may be a C language or a C++ language, it has to be followed by certain steps. That is, let us have a look at it. These steps actually starts learning about preprocessors. That is, the actual processing begins at the time of compilation. Before the compilation begins, these pre-processing tasks are carried out, hence it is called as pre-processing. The software which does the task of pre-processing are called as preprocessors. Let us work out with that. In this diagram, you will see that the C source code, that is the program written in C programming language, is going to be processed or pre-processed. That is, the source program C program is given as input before it is given to the actual compilation. We check whether there is any preprocessors present in it. Then how does the compiler knows that there is a preprocessor present in the program? Yes, of course, the compiler needs to know that there is a preprocessor directives present in a program. Once it recognizes, it can schedule the task of preprocessing to the preprocessor. That is, the preprocessor performs the task of preprocessing once the compiler recognizes that there is a need of preprocessing. That is, the macro directives are included in that. Then the expansion and preprocessing of macros are done by the preprocessor. Once every preprocessing is over, it is given as input to the compiler. The actual compilation or processing begins at the compiler if the directives or preprocessor directives are present in a program. If there is no such preprocessor directives present in a program, then there is no need to give it to the preprocessing. Directly the program can be given to the compiler. After this, the compilation begins and then the object code is generated from the compiler. The output of compiler is always an object code which is given as input to the linker to link few of the programs, that is having the function definition with function call, and all of the libraries which needs to be included in the program are going to be linked by the linker. Once everything is over, the .exe or the executable form of the program is generated and the system starts executing. If you look at that, Alt F9 is the keys we press to compile any of the C program, and for executing the program we press Ctrl F9. When you press the Ctrl F9, the executable program starts given working to the executable processors, that is the .exe file is given as input to the execution environment, then the execution begins, that is starts running the program. That is how the workflow goes on. Now in this case, you can see that the intermediate steps in the above program, that is in the diagram, intermediate steps, this is one of the intermediate step, this is another intermediate step, after this is another intermediate step. All these are called as intermediate steps. The source code written by programmers is stored in the file program.c, that is with the .c extension or .cpp, also called C++ extension is given to it. This file is then processed by the preprocessors and an expanded source code file is generated named program. Once when the pre-processing is over, the expanded file is generated. The expanded file is given as input to the compiler for the purpose of compilation. If that is the case, this expanded file is compiled by the compiler and an object code file is generated named program.obj. Similarly, if you look at the .java files, .java or .c++ or .c files, all these files are given as input in the same high-level language to the system. But before the actual compilation, the pre-processing is carried out and then the compilation of the source program is carried out to perform the task of any error checking present in it. That is, the error checking is performed with the compiler. Now, finally, the linker links the object code file to the object code of the library functions to generate the executable files, that is program.exe. As I have already told you in the previous slide, that is once when the expanded form is generated, it is given as input to the compiler. The compiler takes the expanded form of the file as input and then it generates an object program, that is the intermediate file of a program which is not in readable format. Once when the object file is generated, it is given as input to the execution environment, that is to the linker. First, linker is the one that links each of the libraries or any of these programs which needs to be linked from one point of location to the another point of location into one single program so that the execution begins very smoothly. That is how it goes on. Then, these preprocessor programs provide preprocessors directives. I am stating that preprocessor directives, which tells the compiler to preprocess the source code before compiling. All these preprocessor directives begin with a hash symbol. That is, this hash symbol indicates that there is a preprocessor. There is a preprocessing required for in the program. This symbol indicates that. The hash symbol indicates that whenever statement starts with hash is going to be the preprocessor program and preprocessing begins the execution or the expansion of the original source program. Now, if you look at this, include is one of the statement which is preceded by hash symbol, hash define, where define is a directive that is preceded by hash symbol, hash if n def preceded by hash. So similarly, we have various other type of preprocessor directives. These directives are preceded by the hash symbol to direct the compiler that there is a preprocessing required in the program. If that is the case, remember that the symbol hash provides a path that will go to the preprocessor. And commands such as include is processed by preprocessor program. That is, we have this include. In case of this, we can also write down that #include in programs IO stream within this angular brackets. This angular brackets indicates that please include the file named IO stream, that is input output stream. Input output stream file is to be included because the functionality of input output operation is to be carried out in the program. That is why we are going to use the IO stream there. Then for example, include will include extra code to your program. Then we can place these preprocessor directives anywhere in our program. We can place these directives anywhere in our program. Let me take you into the example of this. There are 4 main types of preprocessor directives. The very first one is macros, then file inclusion, third one conditional compilation, fourth one other directives. In this case of this, let us learn about these directives one by one. Which is the first one? Macros. How the macros are defined? Which was explained in the earlier session, that is in the previous session. Macro instructions are placed in the program. Those instructions are replaced by the definition before the actual compilation begins. That is called as a macro expansion. Similarly, we have a file inclusion which can be done using the symbol, that is #include IO stream within an angular bracket that enables you to include any of the files into your source program so that the linker can link those functionalities of those files in your program for the purpose of execution. If that is the case, let us see to it one by one. That is macros. Macros are a piece of code in a program which is given with some name. Whenever this name is encountered by the compiler replaces the name with the actual piece of code. That is, #define is a directive, is used to define a macro. Let us now understand the macro definition with the help of a program in the next slide. That is, here we have #define limit 5. What is the meaning of this? We have a define keyword here. This is a macro and it is preceded by an symbol. That is, a directive is needed. Preprocessing direction is needed for this program. What is the name of the macro? We have a limit. And what is the value associated with the name of the macro? Limit 5. In this case, I have a for loop here. In the for loop, I have the value limit here. In the place of limit, it replaces the limit by 5. That is, the value of int I is equal to 0, I less than 5, I plus plus. This indicates that the conditional statement, that is the conditional value limit is placed inside the looping statement, defines the number of times the for loop is to be executed. That means we have the limit 5 here. That means I is equal to 0, I less than 5 means 0, 1, 2, 3, 4. 5 times the statements are executed. That is 0, 1, 2, 3, 4 is printed and finally it returns the value 0. That indicates that wherever the macros are defined, the values associated with the name of the macro is placed into that before the actual compilation. That is, if there is a directive, macro preprocessing directive, that is expanding the information which is enclosed in the program. Similarly, if you look at this output, you will see that the value is printed in this order, that is 0, 1, 2, 3, 4. In this program, when the compiler executes the word limit, it replaces it with 5. The word limit in the macro definition is called a macro template and 5 is a macro expansion. The limit, this is called as a macro, limit is called as a template and the value is called 5 is called as a macro expansion. Wherever the limit is encountered, the value 5 is replaced by that. So there is no semicolon. There is no semicolon at the end of a macro definition. That is the macro definition. Macro definitions do not need a semicolon at the end. That is, in this case, there is no need of this semicolon at the end of the statement to call it as a statement, because since it is a directive, no need of semicolon at all. That is, no need of semicolon at all at the end of this macro definition. Now, you will see that macros with arguments, similar to the functions with arguments, you can replace the macros with arguments. If that is the case, these are called as parameters or arguments. Area of L comma B. This is called as a preprocessor directive, that is hash symbol. Int main is the function. Let us see to it. I have an area of L1 comma L2, where L1 comma L2 are assigned with the values 10 and 5. Area is a variable that is assigned with the calculations of preprocessing. That is, wherever the area of L1 comma L2 is encountered, it replaces it by L1 star L2. That is, which is same as 10 star 5. So, which is equal to 50. The area is assigned with the value 50. If that is the case, area of rectangle is 50. This has to be the output of this. Yes, if you look at this, you will see that clearly area of rectangle is equal to 50. We can see from the above program that wherever the compiler finds the area of L comma B in the program, it replaces it with the statement L star B. That is this, L star B. That is L1 comma L2, L1 star L2, L1 comma L2 are replaced by L1 star L2, because I have the thing that is L1 star L2 as the statement, where L comma B are called as arguments. So we have that. Then the values passed to the macro template, that is area of L comma B, will also be replaced in the statement L star B. Therefore, area of 10 comma 5 will be equal to 10 star 5. The same thing which I explained right now. That is this. Next, we have the macro preprocessing. That is the second type of processing, that is file inclusion. How these files can be included? That is, you can use any of the existing files, that is the built-in files, into your program, or you can include any of the user-defined files into your program. That is also possible here. That is, there are two types of files used in the program or included in the program. One is the standard header files. What is the meaning of standard header files? That is hash include IO stream or hash include stdio.h. That is hash include stdio.h. This is a file with an extension .h is going to be included into the source program, so that the functionalities such as scanf and printf are going to be included in the program. With the help of this printf and scanf, I can receive the input from a user and print the output to the user. The same, these operations can be performed with the help of this stdio.h file. So, I am including this file into the existing program with the help of include directive. So, that's why I am using this as hash as a directive, which includes the file into the source program. The same thing is explained here. That is for performing the IO operations, that is IO stream, stdio.h. These are some of the input files I am using, that is into our source program. This is an existing or predefined functions or predefined files which is already available in your code, that is in your source program. How did you get that source file? By writing the program. How did you incorporate that functionality, that is inbuilt functionality, into your source program? That is possible by including the directive include, which includes the file named stdio.h into the program, so that the functionalities such as printf and scanf can be used in your programs. If you do not include this stdio.h into your program, you can't use the scanf and printf functions in your C programs. That is why we have the include directive that includes the file name into your program. That is a predefined file name into your program, inbuilt functionality or inbuilt library into your program. Suppose if you want to include your own user-defined function into your program, you can do so by doing this functionality, that is hash include some file name, that is hash include some file name called file1.h. This includes the file named called file1.h into your source program. Suppose if you want to find out the factorial of a number, you can do so by including the file name called file1.h. The file1.h must contain the definition for finding the factorial of a number. That is how. Similarly, we have the user-defined function, that is file name. The same thing is explained here in this slide. It is a very good practice to include the user-defined files into your source program so that the execution is carried out very smoothly in our programs. Then these user-defined programs and files are, when a program becomes very large, it is a good practice to divide it into a smaller files and include whenever needed. These types of files are user-defined files. These files can be included as include filename.h. This is how we are going to include our own user-defined files, that is file1.h. This is how the user-defined functionality or the functions of the pre-processing can be incorporated into our source program. Thank you very much. Thank you one and all.